Hi guys, this video is sort of a continuation of the last one that got posted, looking at balancing ionic equations. What we went through and did last time was take a single replacement reaction and break it down into its component pieces, its oxidation half and its reduction half, and then combine them into one big happy equation showing how species got oxidized and how they got reduced. Now, you may on occasion see an overall net ionic equation that isn't balanced. So you don't get just the full starting reaction, you get the net ionic equation. But what you will notice is that it's not conserving charge. Over in this particular example, we've got +3 on the left and +2 on the right. Last time I checked, 3 is not equal to 2, so this does not conserve charge. And that should make you panicked, but not really, because fixing the scenario is actually quite easy. All we're going to do is work in reverse and try and identify what gets oxidized and what gets reduced, and then kind of fix the equation by making sure that number of electrons lost is equal to number of electrons gained. Because whenever you make that adjustment, you're always going to be able to conserve both mass and charge. So let's break this particular equation down a little bit. What I see immediately, because the charges are already written there for me, is that zinc 0 is the species getting oxidized. So zinc 0 is changing into zinc 2+. That's going to require the loss of 2 electrons. Nickel +3 is getting changed into nickel 0. That's reduction. The charge goes down. So nickel +3 is changing into nickel 0. Again, that's going to require electrons to be gained in order to conserve charge. So it'll take 3 of them to make sure that both sides are equal to 0. What I notice is that 2 is not equal to 3. This is the dilemma we were having in our original equation. We need to make some adjustments so that this number of electrons lost is equal to this number of electrons gained. Again, it's not that easy to turn 2 into 3, but it is easy to turn 2 and 3 both into 6. So what I'm going to do is multiply my oxidation half reaction by 3 and my reduction half reaction by 2. And what that's going to do is create coefficients on zinc of 3 and change my number of electrons to 6. And it's going to create coefficients of 2 on my nickel species and change my electrons gained to 6. Immediately, you can see, even without writing out the whole net ionic equation, this directly corresponds to our original problem. So if you feel comfortable, you can go ahead and fill in, oh look, I've got a 3 out in front of my zinc 0, a 3 out in front of my zinc +2, a 2 in front of my nickel +3, and a 2 in front of my nickel 0. This conserves both mass and charge because my number of nickel atoms is the same on the left and the right. Same deal with my zinc atoms. And now I've got +6 on the left and +6 charge on the right. So both mass and charge are conserved. If that wasn't immediately visible to you, what we can do is go through and again write out and combine these two half reactions to create 3Zn0 plus 2Ni plus 3, changing into 3Zn plus 2 plus 2Ni0. So combining these two half reactions, everything on the left with everything on the right, I end up with something that matches up here. So finding those coefficients, the easiest way to do it is to just break it down into half reactions that you guys are so good at writing, and then making sure you're multiplying by an appropriate number so that electrons lost will always be equal to electrons gained.